Let us try to understand what are inequalities. And before getting into details, let me introduce you to some examples which you see and come across every day. So these are few examples here which will introduce you to how we use inequalities in our daily life. So the question here is, write a linear inequality for the given situation. Now the first one is temperature below 0 degrees. The next is height above 1000 feet, age between 12 and 20 years, distance not less than 100 kilometers, speed up to 80 kilometers per hour. So you see, in our daily life, we always use inequalities in some way or the other. Now today, we will try to see how to represent them in the form of numbers and on a number lines. So this playlist will include innumerable examples on solving inequalities, but before that, let's understand what are inequalities, right? And then because this is a vast topic, as you can see from the set of examples, that we can go forever. So I have three different playlists on inequalities. One linear, the second non-linear, where we'll have quadratic and polynomials, and then we have absolute inequalities. So these are the three playlists, and we'll see how to solve inequalities algebraically, graphically, and how to represent them in many different ways. So explore this, and I'm sure you'll enjoy this set of videos and learn a lot. Now, let's get to the basics. That is, why do we do it, right? And how do we apply it? Now, here, temperature less than 0 degrees, how can we represent this in terms of inequalities? So let us first define a variable. Let's say T is temperature, and T belongs to set of real numbers, because temperatures could be anything, negative or positive, any decimal numbers. So T belongs to real numbers is the variable defined for temperature, and then we'll represent this in the form of inequality, and it is very clear here, temperature below 0 degrees, right? So in inequalities, you will see we are not using equal to sign. We are using signs which are greater than, less than, or combination of greater than, equal to, and less than equal to. Here, temperature below 0 degrees. That means 0 is not included. So we say T is less than 0, right? And here we are defining temperature belongs to real number, and it is measured in degrees centigrade, right? So we'll write a statement defining our variable T, and then we say temperature T is less than 0. So this symbol is for less than, okay? So whenever you write this, then T, this is a smaller end, that's a bigger end, so T is smaller than, this is the number 0, okay? So that is how you can represent it in the form of inequality. The next one is height above 1000 feet. So let's define our variable, and let's say let h be the height in feet, okay? In feet, and h of course will belongs to set of real numbers, right? Because it is any real number. So height above 1000 feet, so h belongs to set of real numbers, and we can write this as an inequality saying that height is greater than. Above means greater than, not including 1000. Greater than 1000, right? So that is how we will write it in inequality. Now from both the examples you've seen one thing, I'm not mixing units when I write numbers, right? So units I have defined along with the variable separately. So whenever you're working on inequality practical examples or real life situations, don't mix up units in between. Define your variable along with the units, okay? And when you write down your answer, then you can include the units. Okay, let's move on to the next example, which is age between 12 and 20 years. Now let A be the variable defining age in years, okay? So let A be the age, okay? Now it says between 12 and 20. That means we are given two boundary conditions this time. Lower bound is 12 and maximum is 20, right? And A, the age is in between these two. Now age has to be greater than 12 and less than 20. So these are the symbols which represent age A greater than 12. So this bigger end comes as a greater. Age is greater. In this case, 20 is greater. 20 is associated with the bigger end of this inequality. Do you see? So in inequalities, we are using symbols like less than or greater than, or we also use now, I'll show you some with equal to sign included. So that is less than equal to, and then we have greater than equal to. So these are the symbols which we are going to use. So let me write these symbols separately here right on the top. So we have the symbols which we are going to use, which are less than or greater than or less than equal to or greater than equal to, correct? So these symbols we are going to use with our examples. The next one is distance not less than 100 kilometers, right? Let me define my variable again. Let's say distance d is in kilometers. Now if I don't say belongs to the set of, it means real numbers. Okay, distance not less than 100 kilometers. That means it is greater than or equal to 100, correct? Not less than, right? So it could be 100, it could be more than 100. So we say distance is greater than equal to 100. Do you see that? So that is how we represent this situation as an inequality. Distance greater than equal to 100. Note, we have associated greater than along with equal to. So distance could be 100, 101, 200, 500, 1000, any number but greater than equal to 100. So that is how we are going to represent this situation. Now the last one for us here is speed up to 80 kilometers per hour, correct? Now let's define a variable, let's say velocity. We'll use velocity v to represent speed in this case. V as speed in kilometers per hour. Now v is representing speed in kilometers per hour, and we say speed up to 80 kilometers per hour. That means it cannot go beyond 80, but it could be up to 80. That means v, I will write here v less than equals to 80. So that means it is up to 80 kilometers per hour, right? Now, I'm not getting into details of lower bound because we know speed will always be positive, distance is always positive, so we know it is from 0 to 80, and the distance in this case is from 0 to 100. But we are not getting there now. We are translating what is given to us. In some practical problems, we may have to and we should write down the limits also. That means the lower bounds or the lower, what could be the minimum also, which could be derived from the given situation, right? If this would have been a part of a word problem and we say distance not less than 100 kilometers, I should have written from 0 to 100, knowing fully well the distance is positive. In this case, speed up to 80 kilometers per hour, that means it is from 0 to 80, right? But we are not writing it yet because the whole picture is not clear to us. We have a phrase and we are converting that phrase to algebraic notation. In this case, inequality. I hope with these examples you get fairly good idea of what we are getting into. Now, just following this example, we'll have numbers and we'll represent numbers in the form of inequalities, and then we will start to see how to solve simple inequalities and get into complicated ones. I hope that will be a good learning process and you will enjoy it. Thank you and all the best.